Hi, everybody. Welcome to today's webinar with Blues and Geocene. I'm your host. My name is Jim Hassman, and I am the President and Chief Revenue Officer of Blues. The topic for today's webinar, as you see on the slide here, is the keys to cloud-connected sensors in challenging environments. And Danny from Geocene is joining us today, and he and I are going to have a really fun conversation with all of you.
Hey, folks. Hey, folks.
There's Danny. I'll have Danny introduce himself in just a minute. I've been with Blues for a couple of years now, as we have been working on our go-to-market motion. And Blues is a hardware-led SaaS company. For those of you who may be new to us, we have these tiny little communication devices, or modules as people call them, that get inserted into all kinds of products to help product designers and product manufacturers connect these solutions to the cloud and do that very cost effectively, very quickly, securely, safely, and obviously secure. I may have mentioned security twice, but we're in all types of industries. Everything from industrial to energy to oil and gas to refrigeration and cold chain, healthcare products, electric vehicles, mobility, or e-mobility, battery storage, and even porta potties. Believe it or not, connected porta potties are now becoming a thing. And I don't think they're going to turn the clock back. But yeah, all kinds of products. And why do people use Blues? Danny's going to tell you his version of this, but my version is we simplify the hell out of connecting products to the cloud and take a bunch of hard work off of developers so they can focus on designing good products instead of worrying about connectivity. And so that's Blues. Thank you all for joining. Danny, why don't you tell them a little bit about yourself?
Hi, folks. Hi, I'm Dr. Danny Wilson. I'm the CEO of Geocene. I'm here at Geocene HQ in Berkeley, California. We're a company that helps other companies build smart connected devices. As proof of it, I've got a big mural behind me of a bunch of the projects we've built. That's the Earth as a circuit board, and it's all covered with various gadgets and projects and products that we've built over the years, and a few of them are behind me as well. I came to the IoT space from aerospace. I used to work in the aerospace sector, but I came to Berkeley to do a PhD on IoT sensors related to global development. Basically, how could we use IoT and connected devices to improve international development programs? And so I've done connected device projects all over the planet, especially in poor countries. And as you can imagine, the connectivity challenges there are extreme. Geocene doesn't just work on connected devices for the developing world. In fact, most of our business is building smart connected products for startups and large companies alike. And we're a rent-a-brain team. My superpower is surrounding myself with really, really brilliant embedded systems engineers. And when you need to build a new smart connected product, we join your company for anywhere between months and a couple years and build that product for and with you. So that's me.
Awesome. Well, are we ready to do this?
I'm ready.
Okay. You told us a little bit about how you got started building products in IoT, but maybe tell us about your first one and what kind of launched all of this.
So my very first IoT product that I helped with is actually right there, that little green box. That green box is both a cellular and satellite connected water pump monitor. So if you're way, way out in East Africa, on the Horn of Africa in the Rift Valley that runs down Ethiopia and Kenya, there's a lot of drought challenges. And there's a network of large water pumps that are supposed to turn on when it stops raining. And those water pumps are not small. They're large diesel or solar array powered water pumps. And they've got deep boreholes that are drilled into fossil aquifers. And as you can imagine, these are really important for the health and vitality of whole communities. In fact, I can show you a picture of what one of these looks like. I will share my screen here. Well, I thought I was going to share my screen. So here's a picture of what it looks like out there. We have a lot of these pumps monitored. Obviously, we're not looking at the pump now. We're looking at a trough of water that feeds animals. And the water pumps are sort of critical for keeping these animals healthy and alive. And here's that green box, that same box that's behind me right here. You can imagine in a situation like this, these water pumps they're not just difficult to connect. They're extremely difficult to connect. You're a one-day motorbike ride away from civilization. So there's no Wi-Fi. There's no cellular networks. There's just camels and goats and dirt and one water pump in the middle of nowhere. So yeah, you can see that the sensor's solar powered. That creates extra challenges, sort of having persistent connectivity with only solar power, because there's no grid power out there either. And then the connectivity solution for these particular devices was Iridium short burst data, Iridium SBD. And we operated these on Iridium SBD for several years before adding cellular connectivity to them for the pumps that were near cellular networks. So why does all this matter? It matters because these pumps are critical for people's livelihoods, and a lot of times they break. And when they break, there needs to be accountability to go fix them. And essentially what these devices are doing is they're monitoring the pumps and they're looking for faults. They monitor the three-phase power that runs from the inverter or the generator down to the pump itself. And it runs some machine learning that predicts pump failure, or if the pump has already failed, it reports a flag that this pump is down. And this fleet of devices keeps watch on hundreds of these drought management pumps all over East Africa. So that was the first project. This was done for a company called SweetSense, which is now called Viridi. And it's a wonderful company based out of Boulder, Colorado.
Awesome. Great story. You talk about Verity and this journey, but I'm aware of some of the projects you've worked on. And it seems like the projects that you've worked on all have the similar trend, is that the environments that these things end up getting deployed into have challenges. How would you describe a typical Geocene IoT customer, and how are they different from maybe other types of IoT customers?
Our typical IoT customer tends to be a startup. We work with a lot of either venture-backed startup teams or organizations with sort of an internal startup mentality or a new product development process that's sort of independent and operating autonomously from the larger organization. We also tend to specialize in remote, off-grid, solar-powered, difficult connectivity solutions. So, that could be something like, here's the Arable Mark III weather station. So this is both a weather station and a whole field crop monitor. It's really cool. It's got downward looking spectrometers that can assess the photosynthetic activity of the crops. It's got upward facing spectrometers to look at the incident radiation coming down on the crops, has cameras, rain gauge, wind, temperature and humidity, obviously. And it's all powered by a solar panel. And it's out there in difficult environment in the middle of the field. So this would be a classic Geocene project, right? This is a difficult to network solar powered IoT device. Another interesting project is the Sofar Spotter ocean buoy. So another, you see the solar panels here on top of it. You see somebody hucking it into the ocean. Talk about difficult environment, both physically with the salt water and the immersion, obviously. And then the fact that, connecting to networks is a real challenge. So this is another startup building a new product that we worked with. This product also worked on Iridium SBD, connecting to the satellite networks. But in situations where the buoy is floating close to shore, do you see the mountains here of the San Francisco Peninsula? When the buoy's this close to shore, oftentimes it can still connect to cell networks. And so what we did is we integrated Blues wireless cellular note card into this buoy. So now it has both satellite connectivity when it can't see the cell networks, and it has cellular connectivity when it can see the cell networks. That cellular connectivity through Blues is, I don't know, 100 times cheaper and 100 times faster and 100 times better than the satellite-based Iridium short burst data. So we like to use cellular whenever we can, and then we use satellite when we have to. You'll find in a lot of these projects that was the same with this green box for Verity, right? It uses cellular when it can and satellite when it has to. And that's a sort of design paradigm we've fallen into several times, is having to have, the main cellular connection and then the satellite for backup. And because lots of people fall into that, we got used to building that kind of architecture, but it's a shame because the satellite modems are expensive and large, and they're like a whole separate system from the cellular system. So I'm really excited about some of this new cellular NTN, like non-terrestrial network stuff coming up, where we can potentially send cellular data directly to space and only have to deal with one set of connectivity hardware. And I think a little birdie might have told me that Blues has something related to that. Jim, can you say anything about that?
Yeah, maybe this is my commercial break.
Sure,
But
sure.
yeah. So yeah, exciting news, everybody. Danny's correct. I think today I have not actually been online yet to see the press releases, but I was told that the press releases were going to come out today announcing a new product from Blues called the Star Note. And the Star Note is exactly what Danny just said. It's a cellular NTN capability of using cellular over satellite. And that product was just announced. It's on our website. I think if you go to blues.com/starnote, the website was launched live this morning. This now gives Blues customers and developers the ability to swap and to fail over cellular, LoRa, Wi-Fi, and satellite with one single API. Okay, no one on the planet does this. API to the cloud, to be clear. And so that should really help with these types of projects where you don't know if you're going to have cellular service, or you don't know if Wi-Fi or LoRa is going to work, and you might need a satellite backup. This is kind of really cool stuff. So anyway, thanks for plugging that, Danny. And at some point today, I'll go read what the press is actually saying about it.
I'm hyped up about it because, you don't know. I mean, one of the biggest challenges with these projects is our customers ask us, okay, well, when I deploy my weather stations in a field in Brazil, or I deploy this water pump monitor somewhere in the Rift Valley, am I going to have cell service? And the truth is, there's no global cellular coverage map. You go to any of the sort of data sets from the large providers, and they have sort of either sort of comical coverage maps where they just highlight an entire country, green, we've got coverage here. Or, maybe there's a little more granular map, but each pixel is 100 miles by 100 miles. But
you call them and they're like, we should have coverage there. And if we don't, we can give you a booster. And you're just like, I might as well just go test this myself.
Totally. Right. So we send a lot of people like in trucks
Yep.
with, a cell phone with a variety of SIM cards to like really get the real sense of what's available at the particular locations where a customer wants to deploy. So, and you know, you don't always have a choice. You don't always have a choice. And when you don't have a choice and cellular or Wi-Fi or LoRa isn't an option, is awesome to fall back on satellite.
That's great. You know, you talk about working with startups, and I've worked with, this is my second startup in my career. The last one I was at was a 12-year journey. We took that company public. It was really, really fun. It was a fun ride. It was really hard. And
That
I
was an
think
AI startup. Is that right?
yeah, the AI startup. I think that's one thing that all of these people have in common is how hard it is, especially when you're dealing with hardware,
Yeah.
to take an idea, take it to market, and actually start making money. And time is not on your side. Which you know, I think at the end of the day, when you look at what Blues provides, what we actually give developers is time. We give product manufacturers time, because can somebody develop a connected product without Blues? Yes. Can you do it much faster with Blues and maybe more cost effective? Yes. So when you look at the customers you work with, talk about the journey of how you take them from, like, what if you're making 100 of something to what if you're making hundreds of thousands of somethings, and the way that you help customers think about the unit economics as you're kind of going through that journey.
Yeah. I'll get to the unit economics, but you said something interesting, which is that development time. And I think I talked about these two projects, this water pump monitor with a cellular and Iridium SBD modem in it. And then this buoy that also has an Iridium SBD and cellular modem in it. But the difference between the green box behind me and I'll just grab them. Here's a green box. And then we've got this buoy here. So the difference between these two is that this has a bare SIMCOM modem in it. So we rolled our own cellular connectivity for this. And then on this guy, this has a Blues Notecard in it. This green box, this was like 18 months of pure pain. Like, integrating this SIMCOM modem was very challenging. Then getting it to work properly on the African networks was really challenging. You know, we spent, like I said, a year and a half, not only a year and a half cost of engineering time, but think of it in terms of like the company's total runway and investment, right? The whole time the engineers are screwing around integrating connectivity into the product, the whole company's burning money. So 18 months on the green box. This yellow buoy here, this is about 2 months to get the Blues Notecard properly integrated in there. And that's not just because I didn't get 9 times smarter or 9 times more productive between those two. It's just, it's about, that's about the right order of magnitude, about 10 times easier to integrate a Blues Notecard versus a bare, cellular modem. So especially in new product development, if time to market matters, if you're a company with a runway and you need to get something out the door, don't reinvent the wheel. Like, your startup's intellectual property is not tied into your ability to like roll your own solution with Quectel or Telit or SIMCOM cellular radios, or your own, what have you, LoRa or Wi-Fi module. Just buy your way out of this problem and get on to making the thing that differentiates you.
For those of you that are joining us today, Danny and I got to spend a little bit of time together early in January at the Consumer Electronics Show in Las Vegas, which was it was an amazing experience. It was Blues' second year there. I think we had 20 customers in the booth showing their solutions, and the story Danny just told you all about this time frame situation where I can design everything myself. I can write interfaces to the AT commands. I can do all this stuff. When you talk to any of those customers that were there, the story sounds just like the one you just told, because they're like, the one guy was like 7 years and 3 failures. And then when he used Blues, he actually solved the problem he'd been trying to solve for 7 years in 2 weeks. Like, that one kind of blew me away a little bit. But yeah, let's hit on this unit economics thing where you're
sure.
Yeah, when you're taking a customer through this journey and they're like, hey, can you design this product for me? Here's my requirements. What does that process look like for them? And how do you help them think about what the cost side of this looks like when you're doing tens to hundreds versus when they're starting to think about, okay, now I'm really scaling this thing?
Sure. Okay, so the first thing that matters in terms of the unit economics is what I talked about before, which is how long does it take you to start generating revenue, right? That is a big issue, especially for companies with fixed runway. So we look at sort of a company's burn rate and we look at the time to market, at least from an engineering perspective. And if a company is going to buy its way out of a problem instead of build a solution, then the thing that they're getting back is one, all of the lost revenue potential during the product development process, and then also the cost of the engineers, both during the product development process and then frankly after the product is deployed, right? We have seen quite a few companies who reinvent the wheel on their connectivity solution, and some of them will employ one or even two full-time embedded systems engineers to sort of babysit the fleet, to sort of deal with the problems that are generated from buggy cell modem code, for example. So when you think about unit economics, yeah, like how much money are you spending to develop the product before it goes to market? How long are you waiting to get revenue? And then how much support do you have to provide for the product once it's out the door? Our experience with a sort of like buy it versus build it paradigm is that, engineers are expensive, right? Like a fully loaded engineer, a good engineer, which is the kind of engineer you should employ, in my opinion, this is hundreds of thousands of dollars, right? At least 200, maybe 300, with all their benefits and et cetera. And so making up the cost of that person requires sort of marginal savings on your hardware BOM of like hundreds of thousands of dollars plus margin, which usually doesn't happen until a company were to hit, volumes with at least 5 zeros behind it. So I have yet to see a company developing a new product who would save money by wasting a year and a half to bake a $5 SIMCOM modem into their product versus start generating revenue earlier, make their investors happy, and stop paying for all of these goofball engineers. I guess that's not really serving my self-interest, but sort of stop paying for that connectivity effort sooner.
Awesome. I'm gonna interject and change the conversation just a
Sure.
second because I've been trying to field people's Q&A as
Sure.
been talking. One of the attendees says, can Danny speak about challenging environments that included excessive temperature, EMI, or other radiation, excessive shock from accelerations, or other environments that proved challenging, and how you designed for that? Great question.
Yeah. uh, let me show some pictures again. I'll show you a difficult EMI environment here. Okay, thumbs up here in the pump room. I'm sort of like deep in the sub basement of a skyscraper here in Chicago. And there's some large industrial equipment behind me. And this is a product called the Power Patch. Pretty cool product. Intellectual property was developed at Berkeley. And each one of these little sensors, you see these little white rectangles stuck to these circuit breakers? They stick to the outside of the circuit breaker, and then they measure at really high frequency the three-dimensional magnetic and electric field around the circuit breaker. And then they can back calculate how much power is going through each circuit breaker by looking at the real-time 3D magnetic fields. So This is a real challenge because it's in noisy RF environments. It itself, right? There's pumps behind me. There's also a bunch of RF coming out of the circuit breaker panel. And then it's also a challenging connectivity environment because it turns out, do you see this piece of conduit right here? You know
Mhm.
what's in that conduit? Cat 6. Like awesome, high speed, symmetrical internet. You know, guess what we don't get to touch? The Cat 6. Like these building managers do not want your, startup's IoT product on their network. So, even in a situation where the internet is like 18 inches away, you still have to sort of roll your own connectivity solution and sort of get your data out of the building uh, through your own force of will. So in these high EMI environments, there's there's not a silver bullet, right? Like part of it is developing the proper EMI shielding around your product. You can take your product to good EMI test labs and you can test it there, but it is going to be an iterative process. If there's a lot of electromagnetic radiation, if there's big contactors or switches getting thrown near your product, and particularly if you have sensors that are very sensitive to EMI, you will solve some of it in hardware, some of it with magnetic shielding, and some of it is going to be solved in software in terms of just sort of getting rid of the blips and bops and noises and spikes. So it may not be a very satisfying answer. Besides hire somebody with experience, hire somebody who's solved this problem before, and know that it's going to take some iteration effort to solve big EMI issues.
I can also say
Another,
on the Blues side with the actual note cards that
yeah,
that are used in these products, they are um, the, they're deployed in all kinds of crazy extreme environments. Everything from battery casings on long haul trucks that go from extreme heat in the desert of Phoenix or Saudi Arabia to the Arctics where it's like very cold, it's wet. But it really comes down to like what Geocene does in designing around that.
yeah,
I think it's more about the enclosure and the types of things that you do because the note card, it's probably going to work in almost every environment. In fact, there hasn't been an environment yet that we haven't seen it operate, but uh,
yeah,
coverage aside, connectivity aside. Yeah.
yeah. I mean, I don't think the note card is a uh, particular issue. We this is like a funny sidebar. We once had a development board microcontroller hooked up to a note card. And we thought, this note card's busted. What the heck's going on? Like every day at like 10 in the morning, this thing resets. Like we get problems. Like this must be the note card's problem. And it turned out it was the development board. It was like the development board microcontroller, and it didn't have epoxy or like a plastic case around all of the silicon on the microcontroller. And what happened is every morning at 10 a.m., the sun would come up over the edge of our deck at our office, and it would shine light through the top of the product, through a window that was there to be able to see a screen. That light would bounce around inside the product, and the photons would hit the bare silicon of the microcontroller on this development board and reset it. So anyways, that took a while to figure out. We obviously thought it was a clock issue or some sort of
Yeah. Right.
timer or overflow, and it was not. It was the sunshine. Anyway, but I would agree with Jim that we haven't seen a situation where the note card is susceptible to EMI. Obviously, if the thing you put the note card on, your own board, is full of ground loops and all kinds of various other bad design practices, then you might have EMI issues. I was going to show you one more sort of fun one here. Okay, so this one here, I'll show you this little box. This you see this little white box right here on the wall, and then there's a little shiny metal cable going down to this very hot, very dirty cooking stove. So this is a product that monitors the use of these cooking stoves for carbon finance projects. Carbon finance projects Cell offsets. And one of the ways to save CO2 is if poor folks who typically cook on a rudimentary 3-stone campfire looking fire replace their traditional cooking stove with a higher efficiency stove like this one, they can save wood and save CO2. This sensor validates the adoption and use of this higher efficiency cook stove. And so, one of the sort of general strategies is get the sensitive stuff away from the dangerous area. So here we have this box with its associated circuit board and radio and batteries off to the side. And then there's a K-type thermocouple here with a long wire, and the wire goes into danger town, and the sensor is designed to get up to 1,000 Celsius, and we sort of keep the brain safe and cool off to the side. So sort of like a duh answer, but you'd be surprised how many products with difficult environmental constraints basically come down to get a rugged sensor and put the sensor where it's nasty, and then figure out a way to get the sensitive stuff away from where it's difficult and nasty.
Great. I'm going to do a quick time check. We're just over 30 minutes here on the clock I'm running. We've got about another 12 minutes or so.
Sure.
Thanks to everybody who have been putting your questions into the Q&A. I think that's actually worked pretty well, and I didn't announce that at the beginning, so bad host, but thank you for doing that. We're actually doing Q&A as we go. One other thing I want you to talk to everybody about is, you come into project cycles sometimes at the beginning, sometimes you come into it when somebody's tried and made a mistake. Mm-hmm. What are some of the common mistakes that you've seen throughout your career that companies make when they're trying to develop a new IoT product that might be in one of these challenging environments?
I would say that the most common failure pattern is extreme emotional attachment to your tech debt. So this is like a unwillingness to start over. Sort of keeping the sort of broken product limping along because of the fear of going through the development cycle again. So because we work with a lot of organizations that are building IoT products for the first time, you have to imagine that when somebody hires us to sort of either clean up a mess or build a second generation of a product, they have just been through several years of pain. And when you suggest sort of a new way of doing things, like a Blues note card, or let's switch from bare metal firmware to a real-time operating system, or instead of, sending your data to your own PHP API, let's send data to, let's route data to AWS IoT or Goliath or something. They think, oh God, like not this again. Like I've just been through all this pain. We finally got it working. Let's just throw a Band-Aid on the problems of the day and move on. So that is a really common failure pattern. And that is sort of a one-way ticket to a bloated engineering and quality team that is demoralized because their main job is to like keep this rickety thing going. And it's also a way to spend a bunch of money and make your customers unhappy because you have a brittle product. For most of these companies, the product shouldn't be the problem. IoT is already hard, right? IoT has this unique issue of you have hardware that has to work, firmware, a connectivity solution, usually a mobile app, a back end, oftentimes an analytics pipeline, and then a front end. And all of that has to work before the IoT product feels like it works. So you need to knock out as many of those things as possible by making them not your problem. And because so many products start as like, oh, my former roommate, like he knows how to do Arduino. I used to go to school with somebody and, she once did a project in school sort of related to this. And then the whole product gets sort of built on this rickety foundation from these early design choices. So anyways, Don't be afraid. Move past your tech debt. That's a common failure pattern. Um, I would also say a common failure pattern, particularly for startups, is um, making your product a science project. This happens particularly with machine learning startups, where they don't actually have the solution yet, but they imagine that once they collect a huge amount of data, they can develop the solution. Um, and you end up turning your early customers into sort of data collection guinea pigs and not providing them a lot of value. Sometimes that's just how the sausage is made, and you have to collect data before you can train a model, but you need to have some sort of value proposition from day one that the customers love and are willing to pay for. If the value proposition is just be patient with us, in a year or two or three, our product is going to go from being dumb to smart, and then you'll get a lot of value, you're in deep trouble, especially if you're a small startup.
I love that thread, because for the last 12 years of my life before joining Blues, I was on the recipient end of the machine learning, the deep learning, the NLP, all that stuff.
Yeah.
Trying to acquire these data sets. And so when I saw what Blues was doing with making it easy to cloud connect products and get the data to the cloud very, very efficiently, I was like a little bit jealous that 12 years of my life had gone by and there wasn't that available to me. But yeah, you're right. People would get into these projects and they would spend so much time trying to do the latter, when if they would have focused on the former just a little closer, the latter would have been a lot easier. And they would have got the signals faster and cleaner than they originally wanted, instead of going back and forth, back and forth. One of the, for all of you that are still getting to know Blues a little bit, Blues, we don't really have a services function here at the company. We sell hardware, and then we have this very thin cloud client called NoteHub that passes the data back and forth, and you can do firmware updates through it, and provisioning and a whole bunch of things. But really, it's about getting the data from A to B. But we have built solutions, even though that's not our business. We're not in the business of building what Danny builds. We're in the business of helping Danny put us inside of what he builds and make it easy to connect. But one of the services that we have helped customers with over the years is this thing we call a design review, because we feel that our entire focus is to not only make it easy to cloud connect something, but to reduce the number of spins that occur in these development cycles, because that is the real killer. And it's what kind of takes the air out of the room. We got to go back and start over.
Yeah.
And I know you guys do that really well, but for all of you listening, like when you talk to Geocene or you talk to Blues, like our whole goal is to reduce that, eliminate spins, because we think about it the right way, kind of from the start. Like if you could take a white sheet of paper and say, how would I do this different? That's our kind of way of thinking. So I know time's ticking a lot faster than I had envisioned here. Maybe one more question, Annie, then you can pepper me with something.
Sure.
What was your life as a product designer like before Blues?
Oh, I mean, I think the aspects related to connectivity were challenging. They were demoralizing, right? Like when you're in month 6 or 7 or 8 of fixing your buggy AT commands, and you know that you're not actually doing anything special. There's no intellectual property in what you're doing. There's no, getting your product to talk to the cloud, it's table stakes these days, right? So I guess I would say frustrating would be a word that I would choose. There has to be like an ultra compelling reason to reinvent the cellular connectivity wheel, right? Like Blues employs a lot of great engineers who have spent a lot of time and a lot of energy to get the product as, stable and easy to use and reliable as it is. I'll tell you a story. We one time spent like several months trying to implement OTA on a particular product. And it was on a STM32 microcontroller. And eventually there was just so much pressure to get the product out the door that we shipped it without OTA. So the products that shipped, they're stuck on that particular firmware forever. or at least until somebody can get them in their hand and update them with a cable. And then we were developing a similar project for a company called Wedgeworth. They make these big fertilizer trailers that go around Florida, and they were tracking whether the trailers are still full of fertilizer or not as they drive around Florida. And we also had the same STM32 microcontroller on that product. And we recognize, that Blues Notecard has the sort of system built in, the bootloader and everything you need to do an OT update on the STM32. And we just connect the RX and TX lines, the serial lines. Anyways, I don't want to belabor the topic. We got the OTA working in like 2 days, which was amazing. And half that time was just, changing our layout to connect the right pins on the note card to the right pins on our microcontroller. So, and that feels delightful. So delight and frustration are very different feelings. And especially on something that should be table stakes like connectivity or over-the-air updates, it's great to just have it work.
Mm-hmm. We are like almost out of time, and there are 4 questions in the chat.
Yeah.
I don't know if we'll get through all of them, but we'll give it a shot. Maybe just quick answers because
Sure.
all these. Grant says we have a very harsh physical and environmental application to put the note card into. Would you recommend fully potting the note card / note carrier combination, or is that a bit much to ask of the edge connector?
I have never potted a note card. My intuition is that it would probably work, but I guess my challenge to you would be, have you tried out a high quality IP68 case? Is it possible that a good high quality IP68 case would protect your product sufficiently without needing to pot it? Dylan, my EE's here. Dylan, have you ever potted a device with an edge connector? I'm going to say no. It's okay. We haven't. So, all right, we can move on.
All right, we'll hit the next question. Have you done any gadgets powered by energy scavenging techniques? In other words, no PV or batteries?
Yeah, totally. This thing, well, obviously this is PV to the gateway, but the actual sensor is an energy scavenging current transformer. So remember I told you it monitors the 3-phase AC power? Well, we have these current transformers that clamp on the wires, and the sensor, this is back to the get the sensor where it's ugly and put the gateway where you want it. So you clamp the sensors on the wires, the current transformers scavenge power from the electromagnetic field around the wires. That charges up a capacitor. The capacitor powers an InOcean radio. InOcean is like a super low power radio system. And the InOcean data goes wirelessly into this satellite and cellular gateway, and then the gateway hauls it back to the cloud. So yes, we like InOcean radios for super low power. I would say a lot of the radios now, be it LoRa or Bluetooth or whatever, are so low power though that you should at least consider how far could you get with a $3 battery. If you put a $3 Tataran or other long-lived battery into your device, could you get away from the energy scavenging and just run on the battery for 10 years?
2 more questions. I'll take both of these. Whose cellular satellite module is on the Star Note? I mentioned the Star Note was announced today. It's a quick module. Next question. Any advice for servicing the small business as opposed to these large scale projects? I would say everyone in the beginning is a small business. Even if you're inside a very large company, it starts out with 1, 3, 10 devices, and the process is the same. I know there are scale questions that get a little easier as volumes happen, but I'll end with this. Tracy had asked me a question on the chat earlier about the amount of data throughput that the note card was designed for. It was designed for low bandwidth, low power applications. And I'm going to couple this into a question that I thought was going to come up. Maybe it would have if we had more time, around 5G and what we think of 5G.
Yeah.
Okay. These 2 things are kind of related. And then we'll be done. We'll end, and you guys can hit us up if you have questions. But the modems that would be used today that would actually fit on the note card for 5G are like $300. It's a deal killer for these types of applications. Okay, so that's one topic area of like, can 5G help us push more data through, and the networks are going to be designed different. There is a world, okay, and stay tuned for details. This is my tease. There is a world that is between 5G and 4G LTE that has a wideband data throughput capability. Watch for Blues's announcements coming this spring. Okay, that's all I'm going to say right now. It's a little bit of a tease. It's not ready to be announced yet. Ray's a little bit like Apple. He likes to like get on stage and say, "Hey, everybody, here it is," and I've tested it.
Do you think it could do some? You think it could do some video? Could do
Yeah,
anything like that?
exactly. So stay tuned on that. Blues continues to look out for you guys, continues to evolve. Again, our whole goal is to make connectivity easy and cost effective. But thank you, Danny, so much.
Yeah, of
For
course.
joining us today. This was fun. I always enjoy the time with you. And for all of you that joined us today, thank you for taking time out of your schedule, for your interest in us and support of what Geocene and Blues are doing. So thank you very much. Have a great week.
Thank you, folks. Bye.